The KruseDQM package includes everything necessary in the specs for the Army Corps DQM. We include the dredge plant instrument plan paperwork, as well as all the instrumentation necessary for the work event, and a small PLC cabinet with an Allen Bradley off-the-shelf non-proprietary PLC. All of our software and hardware is readily available off the shelf. All of our instrumentation for the work event, which includes the density meter, the flow meter, the intake and discharge pressure transmitter, pump RPM, as well as a ladder inclinometer, and if necessary, a draft meter and tide gauge. All of our instrumentation is 4 to 20 milliamp standard industrial signals. So really you can use anybody's, any manufacturer with our system. It's non-proprietary and open. We also include the ship's server with our software on it, user-friendly interface, and all of our database. And then we include the computer with the DQM software. I have two applications that need to run. Now the first application is our GPS interface, because our system will run regardless of whether you're using HiPAC or anybody's. It's independent of that. So we need to get in this case, our system allows us to bring all the GPS information in, the tide gauge and draft gauge, and you can select US survey, which you're using feet, so get that selected. So in this case, our draft gauge is not coming in through the network or through the serial. Our draft gauge actually comes into the PLC, so we'll see that in a while. But the draft, in some cases, the customer might have it coming in through a serial port or through the network. We're not using it on this one. It comes into the PLC. The tide gauge is in fact coming in COM5. So in order to change the tide gauge, if you want to change its location, you see you got GPS, tide, and draft. Draft won't be turning on. But in this case, we're going to stop the tide gauge, and you can select it. You got to make sure it's stopped up here before you make any changes, because if it's running, if it's collecting data or seeing the tide gauge, I hit start, you'll see that the tide gauge is grayed out here. I don't know if you can tell by the video, but it is. You can't make any changes. So that's the way you got to make changes if you put it on a different port. Once you open this up, you can go ahead and minimize it. It's still running in the background. You can come over here and see the only way to kill this is to come over here and hit exit. You see it says GPS OPC interface. That's the way you kill that if you need to. So it's running in the background. And what takes advantage of that is the KruseDQM. Now the fact that we are down right now, this pop-up comes up. Anytime you go down, a pop-up will come up. So it's the first thing you'll notice. And this pop-up allows us to select the reason we're down. When it's down, this will pop up, and this is automatically populated from our SQL database, which is in the server, and we collect all of the data that we're collecting that we send to the Army Corps. It's in there in case there's any interruptions, and we can do a data recovery that's over here and select any of the interruption, the date and time that we want to recover that data, and it'll populate the DQM, the Army Corps DQM. So anyhow, with the downtime, we got the selection of reasons down. These are all part of the specs. I'm just going to say miscellaneous right now, non-pay, because I'm probably not getting paid. You'll notice the work event up here, every 6 seconds will flash. And that's per the spec. What that does is it's sending all the information over here. You see they now have the vertical correction and the depth. And our depth is in fact 29.2, and what we do is we take in the PLC code, we take the draft, which is coming from the PLC, and subtract or add it to the depth. So your draft, as you take on more fuel, it'll go up and down. So in other words, everything's relative to the trunnion. However, the trunnion has to be relative to the water level because your tide is water level. So we got to tell it how far the trunnion is above or below the water level. We're not getting latitude and longitude in here right now because we're not hooked up to the GPS. These are all real-time information. You'll see your pump RPM, discharge pressure, your production in cubic yards per hour. Also added, this is coming from the Ronan density meter, the mass flow meter. This is production in tons per hour. And then you have over here your vacuum, and your feet per second velocity, and your specific gravity, which is going to be 1 to 2. I think you're not going to go over 1.4. So that is the work event, and that's real time. If we close this out, we're looking at the overview. We have overview, we've got a contract event. Anytime you change any of these numbers in here, any of this information here, I write exactly what it says in the specs, in the Army Corps specs right here as to what you're supposed to do with that. After you've made any changes here, and this contract is only once at the beginning of the contract, then you click on the trigger button, because that triggers and sends it over to the DQM. We have a station event, and again, I describe what this is about. We have a pipeline event. Anytime you add or subtract pipeline, you have to fill this out. Just for example, say your length is 1,300, enter. Now it's 1,300. After you change a number, hit trigger, because that manually sends it over to the DQM. The only thing that automatically gets sent to the DQM is your instrumentation, and that's the work event. Continue on, you've got a booster event. If you have any boosters, you tell them, whenever you add or subtract boosters, you update this, and again, then you hit the trigger. This is advanced. This happens every period, midnight, every 24 hours. You want to tell them how far you've advanced. In fact, if you hover over it, you'll notice that I have a little tooltip. If you stay on there, it'll tell you to the distance you've had. So you want to change that, hit advance, hit the trigger. And outfall, this is the location, latitude, longitude, location of your outfall. All right, and again, all the descriptions here that I write in my user-friendly interface is what you're going to see in the specs. The non-effective event is when you're downtime. Of course, we already launched, we're already down, so I already populated that. And you can see that here's the function code that goes to them, to the Army Corps. But if you do want to see the pop-up, you can just click there and you see again all the reasons why. See, I just changed the reason, it tells you date and time you changed it. And then back to the instruments. This monitor they were talking about, you can put it on a KVM, the monitor, as well as the mouse, so the operator the leverman upstairs can see all this information, as well as select the downtime, so you don't have to come down to your chart room. So this is your setup screen. You have a vacuum transmitter coming in the PLC. All these are analog instruments. And it's non-proprietary. You can use anybody's instrument you want, and that's the reason we set it up this way. It doesn't have to be a serial input and specific drivers you got to write. So if you change the vacuum transmitter, it's a 0 to 30. If you change it, you just simply enter in. Let's take, for example, a better example would be a discharge transmitter. Pretend you have a 0 to 150 psi transmitter on the shelf. Every transmitter is stamped what its value is from 4 to 20 milliamps. So you can see we have 4 and 20 milliamps. And if it's 150, you just change that number there and hit enter, and it'll rescale it. I don't have to get in the PLC code. So this is the scaling for all your instruments. Calibrating the ladder, first you want to put in the ladder length, which I was told is 76, so I entered that in there. And you want to have the ladder at level. In other words, you want the ladder cutter, or actually I call the suction mouth, exactly level in the same elevation as the trunnion. So I don't care if your trunnion is 10 feet below water, 10 feet above water. You want that on the same level when you hit 0 angle. So that's your 0 angle.